So our project talks about predicting daily desired product demand under Newsvendor optimization problem. I'll take in charge of the introduction part. Moving to the next slides. So a little introduction to the company that we investigate on. It's called Mavgo. It's one of the largest dairy company in Greece. It sells a lot of product to both Greece and internationally. So a little bit in motivation to why we want to predict the demand of Mavgo. So we summarize it to 3 points. First point is increasing profits. Second point is enhancing sustainability. And the third point is saving the environment. And after predicting the demand, we consider following optimization problem. And here are the index of our problem. And here's the objective function we define here. So this is just a classical Newsvendor problem. And we use predicted demand to solve this optimization problem and check the performance of our optimal solution on real demand. And that's it for the motivation part.
So now we will discuss about the data. Based on the data, we have two assumptions. First, we assume that the daily sales data has that daily demand. Second, we assume that all productions and sales are in Kovalia, Greece. In terms of the original data set, we have 13 features, starting from date, daily sales, returns, past year sales, and point of distribution. From the original data set, we found 3 challenges. First is the insufficient data features. The current data set may not adequately predict future sales as it lacks consideration of external factors. Our solution approach is by integrating external data sources such as weather condition and raw milk price. Further, we also see seasonality. Second, there is data quality issues. We solve this by imputation technique by using median value. And lastly, we see the impact of COVID-19 to the data. The training data sets include the year 2020 to 2021. Which were significantly impacted by COVID-19, making it difficult to predict post-COVID conditions. We solve this by focusing on analyzing product types 2 and 3 only that show stable demand and did not experience volatile changes during 2022.
Now we'll discuss the analytics model that we use for our predictions. So first, we split the data into a training part consisting of the first 2 years, and then the testing data consisting of the last year. We use the mean squared error as our evaluation metric in order to emphasize the large errors. And we used several different models ranging from linear or regression to some tree models. And we also keep on working on them, in particular to incorporate the predict and optimize framework. We are using some parameter tuning by using a random search cross-validation, and also some feature selection based on correlation between the variables, as well as p-value significance, and we also use intuition in order to select the relevant variables. So here's the table with our temporary results. So we split them between all the different products, and hopefully we'll keep on improving them as we refine our models.
Our most promising model so far has been the random forest model. Here we have it fitted to both milk type 2 and milk type 3. For our testing data. However, there is still high mean squared error, which indicates that we need to further investigate feature selection and possibly introduce new variables. Here are some more details on the hyperparameter tuning for both milk type 2 and milk type 3. Here, the best model has actually been the one with all the features included, as opposed to the feature selection with correlated variables to the target variable.
So I will be discussing the impacts. We could explore data beyond dairy and into other food products, and also look at specific subpopulations, such as countries or regions. And there were certain trade-offs with feature selection that impacted our results on mean squared error. The overall impacts is that for real retailers, they could forecast demand and optimize the stocking of their products. And there's also efficiency impacts such as minimizing holding costs, reduction of waste, and benefiting the environment. And that concludes our presentation.